Welcome to Two Projects. In this video, we are going to explain the project Analysis of Learning Behavior Characteristics and Prediction of Learning Effect for Improving College Students' Information Literacy based on Machine Learning. Introduction. In contemporary society, information literacy has become an indispensable skill for college students, enabling them to navigate societal demands and facilitate self directed learning. Its significance lies in its role in adapting to the dynamic information landscape and fostering lifelong learning capabilities. Recognizing the diverse learning behaviors among college students is essential for uncovering effective teaching methods in information literacy. By knowing these behaviors, educators can forecast learning outcomes and tailor interventions to suit individual needs. So, this project delves into the unique learning behaviors exhibited by college students with a particular focus on information literacy. It uncovers significant correlations between characteristics of information thinking and subsequent learning outcomes. Through the application of supervised classification algorithms such as decision tree, KNN, Bayes, neural network, and random forest, this project constructs predictive models to anticipate the impact of information literacy on college students' learning. Performance evaluation highlights the effectiveness of these models in predicting learning outcomes. Drawing insights from the predictive models, this project offers tailored intervention strategies and managerial recommendations to enhance the quality of information literacy education. These insights aim to optimize educational decision making and nurture the development of high caliber, innovative individuals in the era of information. Objective of the project. So, as I mentioned earlier, the primary objective is to assess college students' information literacy skills, highlighting their proficiency in problem solving, critical thinking, and other cognitive activities essential for success in the 21st century. And the objective is to construct a predictive model utilizing machine learning algorithms, including decision tree, Bayes, KNN, random forest, and neural network, to forecast the learning outcomes of college students based on their information literacy learning behavior characteristics. We aim to evaluate the performance of each machine learning algorithm in terms of accuracy, precision, recall, and F1 score to determine the most effective approach for predicting students' learning outcomes. And the goal is to provide insights for academic tutors and educators to identify students with varying levels of information literacy proficiency and implement targeted interventions to enhance problem solving literacy among underperforming students, thereby improving overall academic outcomes. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of flow of work. So the first step is import and required packages. In this step, we import essential Python libraries such as NumPy, Pandas, sklearn, Matplotlib, and Seaborn. These packages provide functionalities for data manipulation, visualization, and machine learning algorithms. The second step is exploring the dataset. Here, we examine the dataset to gain insights into its structure, features, and distribution of data. This involves tasks such as checking for missing values, understanding variable types, and exploring summary statistics to understand the data's characteristics. The third step is data processing. So, this phase involves pre processing the data to make it suitable for machine learning algorithms. Tasks include handling null or missing values, normalizing the data using techniques like min-max scaler to bring features to a similar scale, and label encoding categorical variables to convert them into numerical form. The next step is visualization using Seaborn and Matplotlib. So visualization is crucial for understanding the relationships between variables and identifying patterns in the data. So we use Seaborn and Matplotlib libraries to create visualizations such as class count graphs to understand the distribution of target classes and correlation graphs to explore relationships between features. The next step is train and test split. So before building the models, we split the data set into training and testing sets. The training set is used to train the models while the testing set is used to evaluate their performance and generalize to unseen data. The next step is training and building the model. In this step, we train machine learning models such as decision tree, naive Bayes, random forest, k nearest neighbors, and multi-layer perceptron using the training data. These models learn from the input features and target labels to make predictions. And in the next step, as an extension to the project to enhance prediction accuracy, we extend our model selection by employing XGBoost, a powerful gradient boosting algorithm known for its robustness and performance. And for user interaction and testing, we built a front-end interface using the Flask web framework. We incorporate user authentication using SQLite database for sign-up and sign-in functionalities. Upon receiving input from the user, we process the data to align with the model's requirements, and the trained model is then used to make predictions based on the input features. The predicted outcome is displayed through the front-end interface, providing users with insights or predictions based on the input data and the trained machine learning models. Now we'll understand about the algorithms used. So the first algorithm built is decision tree. Decision tree is a popular machine learning algorithm used in the project due to its simplicity and interpretability. It works by recursively partitioning the data into subsets, aiming to minimize impurity in each node, making it suitable for both classification and regression tasks with interpretable decision rules. The next algorithm built is random forest. Random forest is an ensemble learning method that constructs multiple decision trees during training and outputs the mode of the classes, that is classification, or the mean prediction, that is regression of the individual trees. It is chosen for this project due to its robustness, versatility, and ability to handle high dimensional datasets effectively. The next one is naive Bayes. So naive Bayes is a probabilistic classifier based on Bayes theorem. It assumes that features are conditionally independent given the class, simplifying computation. In this project, naive Bayes is suitable for its simplicity, efficiency, and ability to handle categorical data, making it effective for classification tasks with limited computational resources. The next algorithm built is k-nearest neighbors. So KNN is a simple yet effective classification algorithm used in the project. It works by assigning a class label to a data point based on the majority class of its nearest neighbors. KNN is suitable for this project due to its simplicity and ability to capture complex relationships in the data. And the next one is multi-layer perceptron MLP. So MLP is a type of artificial neural network that consists of multiple layers of nodes, each connected to the next layer. It is suitable for this project due to its ability to handle complex nonlinear relationships in the data, making it effective for predictive modeling tasks. Now we'll see the comparison graphs. So this is the horizontal bar graph comparing accuracy scores of different algorithms. In this graph on x-axis, I have accuracy scores, and on y-axis, I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis, I have precision scores, and on y-axis, I have algorithm names. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis, I have recall scores, and on y-axis, I have algorithm names. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis, I have F1 scores, and on y-axis, I have algorithm names. F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is dataset folder in which I have required dataset on which we'll train the models. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code data in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained models. This is Jupyter source file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So now use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. So after pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a login link, click on it. So here we have to give our credentials to sign into the system. And if we are new to the system, we have to create an account first. Click on this link to register. As I'm already a member, I'm giving my credentials here and click on login button. So it has redirected us to the predictions page. Here we have to provide all these parameters and click on predict button to get the predictions of learning behaviors. First, we'll understand these parameters. So these parameters represent various indicators of college students' competencies in problem solving, application skills, learning collaboration, knowledge and skills, information awareness, technology proficiency, information behavior, evaluation skills, and lifelong learning. So each indicator, such as IPC1 for problem solving or IT3 for information technology skills, provides insights into specific aspects of students' capabilities, enabling a comprehensive assessment of their information literacy and learning behaviors. So now we'll fill in these parameters. So I have entered the values. Now click on predict button. So here we can see the result, that is student learning behavior is poor. So we can see this student's learning behavior is poor. Click on home. We'll try giving another set of parameters. I have entered another set of parameters. Now click on predict button. So we can see the result, that is student learning behavior is excellent. So this student's learning behavior is excellent. We'll try again. Click on home link. We'll try giving another set of values. I have entered the values. Now click on predict button. So here we can see the result, that is the student learning behavior is medium. So this student's learning behavior is medium. So similarly, we can give any set of parameters and can get the predictions of the learning behavior if it is good, bad, or medium. Now click on logout. So the conclusion here is, through this project, we reaffirm the critical role of information literacy in the educational landscape of the 21st century. Its significance extends beyond academic success, serving as a cornerstone for lifelong learning and adaptation to the dynamic information society. Our exploration into college students' learning behaviors, particularly in the context of information literacy, has revealed significant correlations between cognitive characteristics and subsequent learning outcomes. This understanding is instrumental in tailoring effective teaching methods. By leveraging supervised classification algorithms such as decision tree, KNN, Bayes neural network, and random forest, we have constructed predictive models to anticipate the impact of information literacy on learning. Notably, Extension XT Boost has emerged as the top performing model, achieving remarkable accuracy. The insights garnered from our predictive models provide valuable guidance for educators and academic tutors in identifying students with diverse information literacy proficiency levels. Armed with this knowledge, targeted interventions can be implemented to enhance problem solving literacy and overall academic outcomes. Through the deployment of XGBoost within the Flask framework, we have bridged the gap between theoretical insights and practical application. Users can input student data and obtain accurate predictions regarding learning behavior, thereby facilitating informed decision making in educational settings.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.